Hello everyone. Welcome to this webinar by AWS Thinkbox. Today we will be talking about production in the cloud and a quick reInvent recap with a few more things. My name is Shaya Pandey. I'm a Principal Product Manager with AWS Thinkbox. So let's jump right in. Today we will be talking about AWS building blocks for media and entertainment. Then we will go over announcements from reInvent that we have handpicked, especially for our media and entertainment customers. We'll talk about scaling your studios, customer trends, and go over a case study by our customer FuseFX. So let's look at what AWS core services can be used for various media and entertainment use cases. We have more than 100 services, but the ones that specifically apply to M&E are security, storage, compute, networking, orchestration, CDN, AI, and machine learning, and databases. So the cloud strategy of studios has changed over the last few years. While last year, most of our customers were asking about why they should move to the cloud, now the questions have changed to when, how, and what. And the use cases that they're mostly asking us about are rendering, processing and workflow, machine learning and artificial intelligence, monetization, broadcasts, and data analytics. If you look at the AWS Global Infrastructure, it is built around regions and availability zones. AWS regions provide multiple physically separated and isolated availability zones, which are connected with low latency, high throughput, and high redundant networking. These availability zones offer AWS customers an easier and more effective way to design and operate applications and databases, making them more highly available, fault-tolerant, and scalable than traditional single data center infrastructures or multi-data center infrastructures. For customers who specifically need to replicate their data or applications over greater geographic distances, there are AWS local regions. An AWS local region is a single data center designed to complement an existing AWS region. Like all AWS regions, AWS local regions are completely isolated from other AWS regions. The AWS cloud spans 57 availability zones within 19 geographic regions around the world. And here you can see I have marked out the announced plans for 15 more availability zones and 5 more AWS regions pretty soon. Amazon CloudFront uses a global network of 150 points of presence, 139 edge locations, and 11 regional edge caches in 65 cities around 29 countries. The AWS Global Network is a redundant 100 gig network. It has redundant private capacity between all regions except China, and all traffic between AWS regions makes use of the global network. Now let's look at AWS's compute offerings. AWS Compute Service is called Amazon EC2 or Amazon Elastic Compute Cloud. EC2 offers many different instance types available through AWS, allowing better choice against render profiles. So there are spot instances which particularly fit this use case because they are heavily discounted instances that come from spare EC2 capacity. On top of that, there is the massive scale of AWS infrastructure that lets our customers scale their on-prem infrastructure as much as they want to. And all of these instances are powered by Skylake processors or better. And all of them can be deployed rapidly with no significant wait time at our customer's end. Looking at GPUs, they offer bare metal performance with GPU pass-through mode. There is an option to add flexible number of GPU cards in EC2 instances, and you can use NVIDIA GPUs for remote workstations or headless CUDA rendering. On top of that, AWS Workspaces delivers fully managed CUDA desktops via G3 instances. Looking at the different pricing models, we have on-demand, where customers pay for compute capacity by the second with no long-term commitments. Then we have reserved instances, which need customers to make a 1 to 3 year commitment, in return for which they receive a significant discount over on-demand prices. And last but not the least, we have spot instances. That is essentially spare Amazon EC2 capacity and offers customers a savings of up to 90%. So let's look at how customers use this combination of purchase options. Usually customers use RIs for known steady-state workloads, such as infrastructure. On top of that, customers use on-demand for unknown spiky workloads, such as workstations, when they need to spin up a bunch of GPU workstations to, say, complete a project. And then they scale using Spot for fault-tolerant, flexible, and stateless workloads, such as rendering. Let's look at how to use Spot instances. The simple rule of Spot instances is, first of all, the spot market is where price of compute fluctuations based on supply and demand happen. Number two, you will never pay more than your bid. In fact, you will only ever pay the market price. When the market price exceeds your bid, you get 2 minutes to wrap up. And market price is on average 85% lower than on-demand prices. And lastly, to make the best use of your spot fleet, it's smart to use as many different types of spot instances and diversify your fleet as possible. But now, we have even changed the whole bid system to make it easier for our customers to use Spot without having to think about where to set their pricing limits. So we have eliminated the need to bid, and price spikes are a thing of the past. Now both developers and finance can reliably model spot costs and count on consistent savings. We have now enabled you to launch spot instances in the exact same way you launch on-demand and reserved instances. By simply adding market parameter to the command line, you're good to go. And finally, we have added the ability for spot instances to be automatically paused and resumed with our new Hibernate option. Another industry first. Hibernate is just like closing and opening your laptop, with your application starting up right where it left off. These features extend Spot to more of your existing workloads with less code changes. Spot delivers speed, scale, and cost savings not possible anywhere else, all without breaking a sweat. But what about interruptions? Well, over the past 3 months, 95% of Spot instance interruptions were from a customer manually terminating the instance because the application had completed its work. Moving on to announcements from re:Invent. We have handpicked just a few of the over 100 new service launches at re:Invent because we think these are particularly interesting for Thinkbox customers. So let's jump right in. First of all, Amazon EC2 A1 instances. These are EC2 instances powered by ARM-based AWS Graviton processors. Built around ARM cores and making extensive use of custom-built silicon, the A1 instances are optimized for performance and cost. They are a great fit for scaled-out workloads where you can share the load across a group of smaller instances. This includes containerized microservices, web servers, development environments, and caching fleets. The A1 instances are available in 5 sizes, all EBS optimized by default at a significantly lower cost. And next, this one is one that I'm really excited about, is AWS Outpost. It's a fully managed AWS infrastructure at customers' data centers. AWS Outposts brings native AWS services, infrastructure, and operating models to virtually any data center, co-location space, or on-premises facility. You can use the same APIs, the same tool, the same hardware, and the same functionality across on-premises and the cloud to deliver a truly consistent hybrid experience. Outposts can be used to support workloads that need to remain on-premises due to low latency or local data processing needs. AWS Outposts come in 2 variants, The first one is VMware Cloud on AWS Outposts that allows you to use the same VMware control plane and APIs you use to run your infrastructure. And the second one is AWS native variant of AWS Outposts that allows you to use the same exact APIs and control plane you use to run in the AWS cloud, but on premises. Let's look at the new storage and archiving launches that might be useful for our customers. First of all, Amazon S3 Intelligent Training. It's a new Amazon S3 storage class designed for customers who want to optimize storage costs automatically when data access patterns change, without performance impact or operational overhead. S3 Intelligent Tiering is the first cloud object storage class that delivers automatic cost savings by moving data between two access tiers, frequent access and infrequent access, when access patterns change, and is ideal for data with unknown or changing access patterns. Next, S3 batch operations. It's a new feature that makes it simple for customers to manage billions of objects stored in Amazon S3 with a single API request or a few clicks in the S3 management console. Now, all AWS customers can make changes to object properties and metadata and perform other storage management tasks, such as copying objects between buckets, replacing tag sets, modifying access controls, and restoring archived objects from Amazon S3 Glacier for any number of S3 objects in minutes instead of months. And lastly, Amazon Glacier Deep Archive. It's a new Amazon S3 storage class that provides secure, durable object storage for long-term data retention and digital preservation. This is really helpful for customers who care about storing their data after their project has been done. So most of our customers bring their assets to AWS before their rendering project started, and then these textures and lighting files are used during the rendering job when it's being run. But once that's run, it doesn't make a lot of sense to store that data in S3 at regular storage costs. So this is a good option to just archive existing data like that and use it or warm it up again when they need it for a new project. Moving on to how to scale your studio. So this is a high-level architecture diagram of what hybrid rendering would look like. Let's talk about why is hybrid rendering important to studios. The main reason we hear from our customers is existing on-prem investment. It usually takes 3 to 5 years for a new machine to deprecate. And then most of our customers think about infrastructure in the traditional mindset where compute is a finite amount of infrastructure lying on their on-premises. Secondly, unified pipeline management. If you adopt a hybrid architecture, you can just extend your existing infrastructure to the cloud without changing how you have been doing your pipeline management traditionally. Third, burst capabilities. It lets you expand and contract as your jobs require. And finally, it's a gateway to the future because hybrid workflows provide gateways to all in-cloud workflows. This is an example of a hybrid rendering pipeline as used by our customers. So here you can see that part of their infrastructure lies on-prem, while this area marked in orange is what lies in AWS. These are the deadline AWS render nodes that are preferably run on EC2 Spot. And this is what the deadline AWS portal looks like, where you can preview your jobs that have been submitted, tasks that are being rendered, and which nodes are being run to render your tasks. Moving on to customer trends to understand better how customers use Deadline and AWS to finish their rendering jobs. So usually, if you look at a small to medium studio, they have peaks and valleys of over a week of production. So as you can see in this area, the rendering peaks at just over 24 hours. While for a large studio, this is the submission over a day of production. So the rendering is peaking at over 48 hours. So looking at these peaks, it's easy to understand that a lot of infrastructure that is catering to these is just lying idle in the regular course of time. So initially, when we started, we assumed that what we will be doing as AWS is just catering to these peaks as and when customers need them, which will be just 2 times or maybe even less than that as compared to a customer's existing on-prem infrastructure. But what we learned is that with more capacity, customers can iterate more frequently and artists can spend more time creating. As a result, we found that customers are scaling up to 2 to 10 times their on-prem capacity. They're saying yes more frequently, and time is essentially becoming elastic for them, where they can choose how soon they want to get their job rendered and scale accordingly. The biggest customer trend that we have been seeing is scaling. And before making a scaling decision, our customers usually consider the requirement, diversify their spot fleet across different spot instance types, and then go ahead and scale to get their render jobs done as soon as possible. Deadline 10 helps you pick the right instance types by having you input the minimum amount of CPU and RAM that you need to get your job done. So if you pick the small preset, all the instances that fulfill this requirement of at least 8 vCPUs and 15 gigs of RAM are listed here. And then you can pick and choose from them to decide which ones need to be in your fleet before spinning your fleet up. Let's move on to infrastructure and software. This is what the current deadline infrastructure looks like, where you can utilize your on-prem render nodes as well, and then use Deadline to connect to AWS through a feature called AWS Portal that establishes an AWS Direct Connect secure connection between your on-prem infrastructure and your AWS infrastructure. Deadline offers infrastructure flexibility. So while you can use the default file system that comes with Deadline 10, you also have option to use partner file systems such as Cumulo and Weka.io. Thinkbox offers the AWS Thinkbox Marketplace, which has usage-based licensing. This option enables you to buy licenses for products such as Deadline, Autodesk Maya, Autodesk 3ds Max, and a bunch of other applications by the hour, but you can spend them by the minute. And when you want to use these products on AWS, Deadline comes with pre-baked images for most of these products so that you can just pick the image and start rendering, while AWS Thinkbox Marketplace takes care of the licensing requirements. Let's talk about workstations. AWS G3 Instance type delivers out of the box to the customers. And as you can see here, this is pricing based on a particular region. So please be sure to check the pricing for your own region where you want to run your GPU instances before spinning off your GPU instances. All of these GPU instances are based on NVIDIA Tesla M60. G3 for Excel is half of one M60 with 2048 CUDA cores and 8 gigs of memory. Multiple GPUs for CUDA processing and rendering are offered, but it does not enhance viewport performance. And it supports up to 4 monitors with maximum 4096 by 2160 resolution. This is a snapshot of measured latency across different regions. So looking at a simplified topology, you can see that it's simple to extend even your existing workstation infrastructure to AWS Cloud and then render in AWS so that you don't have to take the extra step of moving your asset files to the AWS ecosystem before you start your rendering jobs. Let's talk about a customer example. Milk VFX is one of our customers, and they were looking to get a significant project done on AWS. The biggest problems that they have was this was the biggest and creative and technical challenge that Milk had undertaken. They needed to do a lot of fluid simulations that require a lot of data, approximately 100 terabytes per shot. Rendering oceans means caching and baking every frame of the shot, and that needed a rendering solution that could scale. So Milk VFX used Deadline to manage on-premises and EC2 spot instances. They peaked at 130,000 cores and averaged at 80,000 cores per day. And Deadline's flexibility allowed for customer development for their pipeline, and the render job was finished in 10 weeks. The biggest benefits that they got were scalability and elasticity of rendering, with AWS enabled a small team to complete the project on time. Milk was able to punch above their weight on a project that typically requires a much bigger team. Another good example of rendering in the cloud is our customer FuseFX. A little bit about FuseFX first. They are an award-winning visual effects facility. They focus on episodic television visual effects, and they have about 350 artists across 3 different offices in Los Angeles, New York, and Vancouver. Right now, they're working on about 100 or so projects. Up on the screen are some of the few they are working on, and of note here is Mr. Robot that has an Emmy nomination. Before we jump in, let's talk a little bit about the key trends in the television industry. There is an upward trend in content and quality that is just continuing to go up and up. A tremendous amount of content is being created. It's being created at 4K and better quality and is hence continuing to push the limits of VFX. In television, most projects are done on a 2 to 3 week schedule, so they have to be super fast, super scalable, and agile, and that's why FuseFX look to the cloud for their rendering needs. To get right into it, this is FuseFX's infrastructure design of how they do it. On-prem, they have a local render farm, an Isilon 1 petabyte cluster with that deadline that is set up with a proprietary studio asset system, production system, and business tracking system called Nucleus that allows them to synchronize files to and from all locations, including the cloud. In the cloud, they use a Cumulo cluster, deadline, and a spot fleet of render nodes. This graph is a fun graph because it shows actual usage. And if you notice the peak on this day here, it has an interesting story behind it. So what happened on this day was that the FuseFX team came to work in the morning and found out that all the renders that had been submitted the previous evening had failed. So the team estimated that they would need 1,000 additional machines to get the project done. However, they were just able to burst into AWS, scale up to 929 machines, and complete 22,000 hours of rendering in a day without having to get any new infrastructure. However, as important as being able to scale compute is, storage lives underneath it all. So when you think about storage, these are the key metrics that impact performance: capacity, IOPS, latency, and throughput. So a customer doesn't always know when the load is going to spike and increase the IOPS requirements. So they need a file system underneath that can be elastic to whatever capacity they might need. And that's why FuseFX used Cumulo, where they started with 4 M416 large instances with magnetic EBS, and then were able to scale up to 6 M416 large instances with SSD, increasing their IOPS from 38K to 80K. So in conclusion, before moving to the cloud, anticipate your workloads, get cloud render ready, and when using spot instances, diversify your fleet to make the best of it, scale your storage infrastructure and software, and use virtual workstations to scale your studio as and when you need it. With that, thank you very much, and thanks for attending this webinar.